side they have taken it out of the scrotum. Okay? It usually is be situated like that. Okay? And then on the other side we see the structures intact. We can see the caudal part of the aorta, and we see the testicular artery running right through the deep inguinal as well as superficial inguinal ring as well as the vaginal ring, or you can say, and then it comes out directly into the testis. Okay, that's your pampiniform plexus. Okay, somehow we only have injected the arteries, not the veins. Otherwise, you usually see like blue and red like intermingled with each other. Okay, so that's the pampiniform plexus. This testis itself. Then epididymis. On the other side, we see head of the epididymis, okay, which is always associated with the pampiniform plexus. Okay. No matter how the testes are oriented, the head of the epididymis would always be close to the pampiniform plexus. Okay, so that's the pampiniform plexus. This is the head of the epididymis. Then we have body of the epididymis, and then we have the tail of the epididymis. From tail of the epididymis, further continuation is the ductus deferens, and so ductus deferens would continue here, and then it will pass through the inguinal canal again, passes through the vaginal ring, and then it comes inside the body cavity. Okay, as it comes inside and opens into the urethra, it becomes larger before it opens into the urethra, which we call ampulla of the ductus deferens. And so this structure here should be identified as ampulla of the ductus deferens. If you just say ampulla, it could be either ampulla of the ductus deferens or ampulla of the rectum, or even ampulla of the duodenum, which is the beginning part. Okay, so make sure you say the complete name, okay, which is ampulla of the ductus deferens. Okay, but before we go to these ones, let's finish the testis, and then we'll go to the other accessory organs and then the urethra and other features. Okay. So this is the tail of the epididymis. There is a connection between the cutting the tree or what? Okay, so what we have here is the tail of the epididymis and the parietal vaginal tunic. The connection between parietal vaginal tunic and the tail is ligament of the tail of the epididymis. Okay, the ligament which is associated with the tail of the epididymis, and then we have another ligament which is on the other side, which is present between the epididymis and the testis, which is called proper ligament of the testis. Okay, so that's the proper ligament here, and that's the ligament of the epididymis, or ligament of the tail of the epididymis. Okay. What about the layers, or what about the membranes that we see here? If I try to put this thing back, then the testis has gone back into the vaginal cavity. By taking this incision, we expose the vaginal cavity. The tunica albuginea is something below this. Okay, so what we have here is we have the parietal vaginal tunic. I am rolling the probe over parietal vaginal tunic and now over the visceral vaginal tunic. The space between these two is your vaginal cavity, which is continuation of the peritoneal cavity through the inguinal canal. And so if I push the probe through the inguinal canal, that's going to end up coming into this cavity here. And that's what happens in the hernia. Like you have abdominal organs passing through the inguinal canal, and they end up going into the vaginal cavity. Okay, so the parietal vaginal tunic, visceral vaginal tunic. Now that's the tunica albuginea, which is when I try to peel off the visceral vaginal tunic, another thick layer is the tunica albuginea. Okay, so that is actually present on the parenchyma of the testis. Okay, these are the structures, or these are different parts of the testis. We can still see the ductus deferens going back. The membrane which is associated with the ductus deferens, that is called mesoductus deferens, and membrane which is associated with the blood vessels and the testicle itself is your mesorchium. Okay, mesorchium. Okay, so that's the mesorchium here, and that's the mesoductus deferens. What about this? The cremaster muscle. Okay, and then when you go to the wall of the scrotum, we have the skin and the tunica dartus. Tunica dartus, okay, Dartos, tunica dartus, which has smooth muscles which helps in contracting the wall and push the testicles upward, which helps cremaster muscle in pulling the testes close to the body. Okay? What is the major function of the cremaster muscle? Either to pull the testicles close to the body or let them go away from the body. And the same function would be aided by the tunica dartus, which has some soft or smooth muscles. Okay? Okay, so now let's look at the urethra, accessory sex glands, and structure of the penis. As we start from here, now we saw the ductus deferens has gone into the body cavity, and as it opens at the neck or at the beginning of the pelvic urethra, which they have transected right here. Okay, so that's the pelvic urethra, surrounded by urethralis muscle. The ductus deferens is supposed to open into the pelvic urethra along with the vesicular glands. Okay, so what we have here, that's the dilated part of the ductus deferens, which is ampulla of the ductus deferens. Then ductus deferens or ampulla of the ductus deferens along with the vesicular gland, they're going to open along the roof of the pelvic urethra. And we have some sort of mound which is present in the center, and the openings are present on both sides. So the central mound is called colliculus seminalis. Okay, so that colliculus seminalis is present right on the roof, along the roof of the pelvic urethra. Okay, so that the central opening or central passage is, what structure is that? Pelvic urethra surrounded by urethralis muscles. Then we have the ampulla of the ductus deferens, vesicular glands or vesicular gland and vesicular gland, one on each side.
Where's your colliculus?
Yeah, colliculus seminalis is going to be inside, so we don't really see that one, but let's see if I can just open the urethra from the ventral side. We might be able to see that structure there. You see that mound here, the central one where we see some black spot. Okay, so we have openings of the ductus deferens, or we can say ampulla of the ductus deferens, and the vesicular gland, which is combined opening of both of them. Those are present on both sides of this mound, which is called colliculus seminalis, okay, or seminal colliculus. Then pelvic urethra is going to continue further. At the caudal end of the pelvic urethra, you see these two glands. Okay, that is the bulbourethral gland, the bulbourethral gland. Okay, now which gland we couldn't see in this specimen? Prostate. Specifically, we could not see the body of the prostate because they don't have body of the prostate. What they have is only disseminate part of the prostate, which we cannot see grossly. Okay, so what is this? Ampulla of the ductus deferens, vesicular gland. What do you call the combined opening of vesicular gland and the ampulla of the ductus deferens? Ejaculatory duct. Okay, and that opening is present on both sides of the colliculus seminalis or seminal colliculus, and then gland which is present at the caudal end of the pelvic urethra is bulbourethral gland. And so both of the bulbourethral gland, they open into the urethral recess. They won't directly open into the urethra. They open into the urethral recess, which is pointing backward, or which is exactly opposite to the cavity or passage of the urethra. Okay, so let's see if we can draw it somewhere. Like if this is the urethra, the pelvic urethra and the penile urethra, and your urethral recess is this way. The cavity is that way here. The bulbourethral gland opens here on both sides. So when your catheter goes into the or towards the bladder, instead of going into the urethra straight here, it might get stuck and go into the urethral recess. And that is one of the major obstacles in passing the catheter from the tip of the penis. And so sometimes you may have to avoid that by using the urethrotomy incision somewhere here, so you can pass it into the urethra, avoiding the urethral recess. Okay? So that's the urethral recess, which is present in all the animals which has the fibrocartilage or fibroelastic type of glands. Okay? So the pig as well as ruminants, they have this one. Okay, so we saw the accessory glands, we saw the structure of the pelvic urethra. Now let's follow the penis. So we have the what bone is that? Ischium with ischiatic tuberosities on both sides, and so we have the muscle which connects the corpus cavernosum part of the penis to the ischiatic tuberosities. That muscle is your ischiocavernosus muscle. On this side, the part of the muscle is gone. We can only see a little bit of that. That is ischiocavernosus muscle. And then in between two ischiocavernosus muscle bodies, you have the bulbospongiosus muscle. Okay, the one in the center. So we have ischiocavernosus on both sides, and in the center you have bulbospongiosus. So the fibers of bulbospongiosus they run transversely. So we can see that muscle there. The fibers are running transversely. Okay. Yep, they're running across the or running like not along the length of the organ. They're running across the organ.
It's called transverse muscle.
Pardon me?
Transverse muscle.
No, bulbospongiosis.
Oh.
Okay, bulbospongiosus muscle only present at the root of the penis. Then further continuation is the body of the penis, which has a very unique feature of the fibroelastic type of penis, which is sigmoid flexion. Okay, and so what you see, the muscle which gets attached to the distal part of the sigmoid flexion is your retractor penis. So we have one on the right, one on the left. Both of them, they are attached to the distal part of the sigmoid flexure in the body of the penis. So their function is to keep the sigmoid flexure and avoid protrusion of the penis from the prepucial cavity. When these muscles are paralyzed, the sigmoid flexure would vanish, it would become straight, and the penis would now come out of the prepucial cavity. Okay? So that's your sigmoid flexure. Now let's look at the transverse section of the penis at this point, as well as we'll probably try looking at it some other place as well. Okay? So what structures we see here? Dorsal and ventral. That's the ventral surface of the penis, and that's the dorsal surface of the penis. That's lateral, that's lateral. So what you see here, this part of the penis, that is corpus cavernosum penis, or corpus cavernosum tissue of the penis. Okay? The part which we see ventrally is corpus spongiosum penis or corpus spongiosum tissue. And at the center of corpus spongiosum, you see the penile urethra. The same urethra which continues further, which is located within the penis, is called penile urethra. So we have penile urethra here, which runs through or which runs in the middle of corpus spongiosum tissue. And this is going to go further down. Then we have the glans penis. Okay. We'll also look at the prepuce. The glans penis, here we see the structure which is slightly bulging, and so we see the external urethral process, and opening or external urethral opening is present right at the tip of the external urethral process. Now what would be the difference between the bovine and the small ruminant? The external urethral process would not be that long. Instead, it would be only at the same length as the glans penis. It won't protrude beyond the glans penis. But remember, they still have separated from the glans penis. So it is attached to the glans penis, but they still have the external urethral process. Only difference is it is not protruding, it is not longer, so it won't protrude beyond the glans penis. But in the small ruminants, specifically in the sheep and goat, you're going to see that protruding beyond the glans penis. And you have the opening or external urethral opening is present right at the tip of that external urethral process. And now you see this one is going to take a much longer time for urinating. Same thing happens in the bull or in the bovine. Okay? Because of the small external urethral opening, they need more or they take more time for urination as compared to the other animals. Okay? Okay, in this transverse section here, what major feature we observe? The tunica albuginea surrounds all tissues of the penis. It surrounds corpus cavernosum as well as corpus spongiosum. And so this penis is not capable of increasing in the diameter. It can only be elongated, and that also because of straightening of the sigmoid flexure. unlike penis of the dog and penis of the horse, which has capability to expand in diameter as well as in length because of the infiltration of the blood into the cavernosus and spongiosus spaces. Okay? What is the responsibility of corpus cavernosum? It gives rigidity to the penis when penis is erect, while corpus spongiosum provides increase in size whenever possible. Like in the horse, in the dog it is possible, but not in the ruminants. And why it is not possible? The tunica albuginea, it surrounds the entire penis. So it is not possible for penis to get enlarged in diameter. Okay? So what will happen here? We just get the rigidity but no increase in size. And elongation is because of straightening of the sigmoid flexion. Okay? Okay, so these are the major features. So what about the blood supply here? At least we can see a blood vessel coming towards the area of the prostate, that is the prostatic artery, which is similar as vaginal artery in the female, okay, which is coming off the internal iliac. Then testicular artery coming straight off the aorta, passing through the inguinal canal and supplying the testes. What about blood supply to the penis? At least we can identify this blood vessel which we see right here.
Sorry, what?
Prostatic. This is internal iliac and prostatic is coming off the internal iliac. Then we have caudal gluteal going outside and internal pudendal continuing further. And remember, your internal pudendal now has responsibility to supply the entire penis. What are the different branches of the artery of the penis? We have artery of the bulb, deep artery of the penis, as well as dorsal artery of the penis. The deep and artery of the bulb, they're going to go like at the root of the penis as well as in the corpus cavernosum and spongiosum. But dorsal artery of the penis is seen outside the penis. So that runs on the dorsal surface of the penis, one on each side. Okay? So we have these three major blood vessels supplying the penis. Okay? The external pudendal has some sort of role in supplying the wall of the scrotum and other features, okay? But really doesn't take much part in blood supply to the dorsal. It might get some anastomosis with dorsal artery of the penis, okay? But in the horse, it is more consistent that anastomosis will occur. Okay? Okay, guys. So these are the major features. Look at the transverse section. Different parts of the penis. Those are root, body, and the glands. Okay, now let's look at the prepuce here. So what we have, the penis is located into the preputial cavity whenever it is not erect. Even for urination, it is not necessary for penis to come out. What we see is this is the internal lamina of the prepuce. Okay? Internal smooth lamina of the prepuce, which usually is continuous with mucosa of the glans penis. Okay? And then this is the external or hairy lamina of the prepuce. And so when you see the junction between or at the place where it turns from internal lamina to the external lamina, that opening is preputial orifice. Okay? So that is the preputial orifice, and that's the internal lamina, that's the external lamina. These are different parts of the prepuce. Now we do have some muscles associated with the prepuce, like cranial preputial muscle, caudal preputial muscle, but I don't think we could really like dissect, or we really need to dissect them at this point. Just know that they are there, otherwise it's not so important. Okay guys, so any other question regarding the male organs? There's one on this side and one, I think one's got cut, that is present on the other side.
Call these guys
Retractor penis muscles.
retractor
Retractor penis.
Okay, and then this is the oval Spongiosus.
Spongiosus muscle.
And then what was the
Ischiocavernosus, that's going to be on this side.
Ischiocavernosus
Mhm.
muscle.
Cavernosus.
Okay.
As like corpus cavernosus tissue, the ischiocavernosus muscle. Because it runs between the corpus cavernosum and the ischiatic tuberosity, it is called ischiocavernosus. I'm trying to probably just open the urethra a little bit, so if we can really trace it to the urethral recess. It looks difficult.